Let's move on to subject of today, which is energy. And I'm going to start with where I left off the other day, which was weight, work, and then we move on to energy. And Appel raised an issue, and he says the following. He says, so-and-so on Quora explains that the moon doesn't weigh anything because it is in free fall. I was saying that you do not need contact. You do not need to put the ball or the box or whatever you put, the pyramid, on a scale. Make contact with a scale in order to have weight, in order to say, oh, now the sphere, the box has weight. No, the box had weight even before you put it on the scale. But this fellow believes that you need contact, that there has to be surface-to-surface contact in order for there to be weight. There has to be this pressure between two surfaces, okay? And I'm saying, no, you don't. And let's show why he's mistaken, okay? And here you see where all this comes from. It comes from Mr. Einstein, okay? And Mr. Einstein in 1907, the time he was developing special relativity, he came up with this notion that a person falling, like in an elevator, is someone cut the ropes and the guy's just falling or falling from an airplane. For him, it's like being in space. He doesn't feel his weight. Okay, so we have this notion today. Objects in free fall do not experience being accelerated downwards, okay, like, for example, toward the Earth or other massive body, but rather weightlessness and no acceleration. Okay? But we have a problem because weight is a gravitational phenomenon. It's defined that way. Weight is equal force acting on the object due to gravity. So do I need a scale to press upon in order to have gravity? Or is there gravity? Or does every object in the universe have gravity? Here, let me show you. Okay, here's a pictorial way of looking at this. Okay, and you can see that everything is interconnected in the universe. Electric universe calls them filaments. Okay, and what you see is that all galaxies, stars, and everything is really connected. They're connected in some way. Okay, physically connected out there, and everything has gravity with respect to everything else. Okay, so this notion that that you need contact is wrong. You had weight before you fell to earth, okay? That's my take on this. I'm saying that everything has weight. You don't know the value because that doesn't matter. What matters is the definition of the word weight, which is a gravitational phenomenon, and everything in the universe, which is an object thing, okay, usually a celestial object of some kind, is gravitationally attracted to everything else because everything is physically connected. Okay? Everything is interconnected. Everything in the universe, all matter is interconnected. Also shows that Mach's principle, that when you twirl around, looks like, being pulled by the stars. Yeah, correct. That's what you're pulling against, in a way. Okay? So everything is connected. You don't need to weigh yourself in order to have weight, because weight is not defined as a contact force. Weight is defined as a gravitational influence of some kind. Okay? And I'm saying that you have weight when you fall to earth. But what Einstein was talking about, and again, it shows the mentality of the mathematicians, he was talking about feeling, what you feel. We don't care what you feel. There are no observers in science. There are no observers in physics. In physics, you have weight, whether you observed or not. The moon has weight, whether it touches something or not. The moon has weight because it's attracted by the earth somehow. We say all the atoms there are connected, physically connected to the earth, and the earth swings the moon around. And this is what's happening, okay? My hand is going to be the earth, and this is what's happening. Why? Because the moon is every atom. Here I have only one string, but every atom in the moon is connected to every atom of the earth. That's why the earth swings the moon around. Space is nothing, so it has nothing. The moon has nothing to scrape its shoulder against. There's no friction. That's why the moon just rolls around and around and around, and the earth rolls around the sun for the same reason. Every atom on the earth is connected to every atom that makes up the sun, and the sun swings the earth around and the moon and the rest of the planets without any friction. That's what's happening. And yeah, we call that gravity because otherwise the earth would fly away. And yeah, there is gravity. The earth has weight, and it's called weight, okay, not mass, okay? Mass is the quantity of matter. We don't count the quantity of matter of the earth or of the moon. We say it weighs so much, and you give the value in kilograms, okay, or pounds or whatever, And that's weight. And you say, well, yeah, because we use mass and weight and mass and weight. Yeah, this is the problem. There is no difference between mass and weight. But these people want to give you the idea that there is a difference. There ain't no difference. Mass and weight are the same thing because they never have been determined in any other way other than through weighing, through contact weighing, which is what this fellow is talking about. But that's not what it is in physics. In physics, we care about the mechanism. And the mechanism, again, everything is connected. Therefore, everything has gravity, which is a falling of something towards another where the ropes fan out. And the reason the earth doesn't fall to the sun or the moon towards the earth is because it's being swung around. So you have centripetal motion and you have centrifugal motion. They cancel each other out. This guy rolls and rolls around, and there's nothing to stop it because there's no friction with space, because space is nothing. Nothing is that which doesn't have shape. That's the way it works. Now we can talk intelligently about these things. Okay, here's what energy looks like. Okay, we're going to talk about energy. I want you to, right up front, I'm going to tell you what it looks like. This is energy. You've seen it here, okay, for the first time. Here it is. That's energy. Okay? So if you ever want to know what energy looks like, there it is. Okay? We have energy. Okay, so I guess the lecture is over. There you see it. We wanted to show you what energy is. There you see it. Nothing more to say, right? Okay, but there's a little bit of a problem. Here we have a fellow, and he says the following. He says, energy is an object. Okay, that's what I showed. Something. There was something there. Whatever it was, there was contrast, there was shape. It was moving. Okay, I showed it to you in motion, but there's something there. There's contrast. Something in motion, that's a something, right? Even though it's in motion, it has to be a something to be in motion. Okay, and I showed you something. Some smoke, some spirit, some whatever you want to call it. That was energy. Okay, and he says it is the deltas between frames. What is a delta? Delta is not a physical object. Delta is a letter. That's what it is. Delta could be a difference. I don't know what delta is. Okay, but then he says energy is the capacity for work. Well, if energy is the capacity, it's not an object. But see, these people just use these words without ever defining them. They don't define the word object. So they can say, yeah, energy is an object. Energy is A, energy is B, energy is C, as long as he doesn't define A, B, or C. He can say whatever. He's got to start by defining object. And if object has shape, you can't say that capacity has shape. Because if energy is a capacity, it can't be an object. And if it's an object, it can't be a capacity. That's how simple it is. But then he says, not any matter, chance, or work itself. So, yeah, if it's not matter, then what is it? It's a concept. Okay, so, yeah, you can't talk about transferring of concepts. Okay, so here you have a guy a little smarter than this guy. His name was Richard Feynman, and she said, it is important to realize that in physics today we have no knowledge of what energy is. What Feynman didn't realize was that energy is not a what. What is what we call a shape. In other words, a what is a thing, a substance, an entity, something, object, whatever those words you want to use. Okay, it's that which has shape. That's what a what is. So you can't say what is energy because it's an irrational question. Energy is not a what. Energy is a concept. Concepts are the opposite of objects. Not really an opposite, but they're in a different category. Okay, it's either an object or a concept. Either you have shape or you don't have shape. If you don't have shape, you're a concept. That's how simple it is. So every word in the dictionary falls under one of those two categories. Either object has shape or concept doesn't have shape. In fact, the word concept is really a relationship between two objects. That's what we invented, all concepts. Okay, so God has to choose whether he's an object or a concept. If he wants to be an object, be the guy who waves the magic wand and makes things appear, fine. He's an object. But God cannot also be intelligence and love and all these other concepts. Okay? Okay, and here's the punchline on that. Yeah, you can't, energy is not a what? Energy is a concept. Okay? In fact, the fact that you define something like energy, in other words, this word, if it's defined, it's a concept. Because objects we don't define. Well, you can't define an object. You can't define the word table. Okay? You point to a table, then you describe it. But first you have to point. That's how we designate objects in physics, in science. And you can't point to energy. What are you going to point to? That smoke that I showed you a little bit ago? Okay, so energy, again, is the capacity, the ability. Those are concepts. There's no physical standalone object called the capacity. Okay, so you can't transfer the capacity. What are you going to transfer? Okay, so concepts have no shape or location and therefore do not move. You cannot move love because love is not a physical object that I can show you. You got to have, love would have to have shape. And then I could move it around, kick it, whatever. I could show you love in motion. I can't do that because, it's not a physical object. And so people introduce these words of ordinary speech and they say, look, love, I can transfer love. I can transfer energy. No, before you can talk about transferring something, you have to show the picture of the thing that you're going to transfer for the purposes of physics. Then you can say, look, I'm going to show you how the ball is transferred from A to B. I can do that with a ball. I can do that with this. Okay. Here I can say, here's at A and here's at B. That I can do. How do you do that with a concept? What are you going to move? What are you going to see? Okay, and so this is where the problem is. These people never define the terms, especially the word object, which is the one that kills all religions. Okay, concepts cannot be transferred from A to B, and there you have energy, just the word that's being transferred. Is that what it is? Okay, so no, you can't introduce terms of ordinary speech or notions of ordinary speech into physics. And physics is literal. And in order for it to be literal, you have to have the object. You have to have the ball. You have to have the square, the cube. Okay, you need to have something. Then you can talk about motion, because the only thing that can move is an object, a thing. Okay, you can't say that you're going to transfer energy, transfer love, transfer intelligence, transfer grace. You can't transfer concepts. But this is how these people talk, and that's what they have in their tiny minds. So they talk that way. Okay, they're religious people in the end. I call them spiritualists because they move concepts around. In the old days, they moved spirits. Why? Because they couldn't see all these mechanisms that Mother Nature has, all these mediators that are invisible and intangible. So they invented this spirit. And it's these people who have taken over mathematics and teach so-called mathematical physics to the new generations. And they learn the same words, but the words are now different. They're called energy. They're called weight. They're called vortex, ether, field, and energy and mass. They have all these terms that they move around, and all those are concepts. You can't move concepts around. First, you have to have an object in order to conceptualize motion. What is motion? Two or more locations of what? An object. It has to be an object. What is an object? Shape. You have to have, it's that which has shape. Then you can be rational. You can talk sensibly. You cannot introduce concepts as objects in physics. Okay, and so the other day we covered work, okay, and it turns out it's associated with this famous word called energy, okay? Anything that is capable of performing work possesses energy. Possesses energy. You mean possess like I possess 2 coins in my pocket? Is that how it possesses energy? Is energy a thing that you can put in your pocket, hold in your hand, throw away? Is that what energy is? Something like that? Energy represents potential work. Okay, so there's this mysterious whatever. We're going to call it energy, X, Z, whatever you want to call it. And now what we're going to be doing is doing work with that. What was work? Well, we talked about that the other day. Work is what? Force applied over a distance traveled. And if you just have that, then you're moving something horizontally, which you see at the bottom. And that's, if the full equation is with times cosine of A. If A is 1, then you have horizontal work. But if you move it up and down, then the question is whether you can use this equation or you have to use the gravitational equation, because you're pulling the box against gravity or dropping it towards gravity, whichever, it doesn't really matter. But you're going vertically with respect to an axis that goes through the center of the Earth. So you're talking about up and down, and you're going to be talking about gravity, pulling or pushing against gravity. Now you have to use the gravitational equation. And then it gets more complicated when you get on any inclined plane, because now you have the 2 components, the horizontal and the vertical component. And again, the way the mathematicians figured it out, they said, we're going to just use cosines, which is, trigonometric accounting system. That's all it is. But we're not learning with that what is physically occurring. See, if gravity is involved in this situation, then you have to factor what? The fact that no matter whether you use horizontally or up and down or inclined, in an inclined plane, what you have is every rope from every atom that forms the object that you're moving in any direction is tied to every atom on Earth. You have to factor that in, and that's physics, because now you can see what's happening physically. You can't do that if you put cosine of A. Cosine of A is just an accounting procedure for describing. It doesn't give you any insight into how gravity works or what work really is. Okay? But again, anything that is capable of performing work is what they call energy. Okay, so now we're approximating a definition, you could say, okay, or at least a notion of what energy is. But here's a clarification: a man standing with a box on his shoulder, right, like this, okay, is not doing any mechanical work. If you're just holding the box there, okay, You're not doing any mechanical work. Nothing is in motion. You're just standing there with a box there, okay? And even though the task tires him, if you have a big box, you're going to get tired, right? But you haven't done any mechanical work. The box could be supported equally well by the floor with no expenditure of energy. So I could put that same box on the floor. There's no expenditure of energy, but we still seem to have some expenditure of energy in there because it's called, well, not expenditure, but we have some energy that is stored. And they call that potential energy, okay? A situation which does not require the expenditure of energy can't be regarded as work. So we don't have work, but we have energy, okay? So we got to find out what this energy, mysterious thing called energy is, okay? Let's find out. Let's see if we can get to the bottom of it. Okay, so here we have a couple people who addressed it. Remember in the 19th century, it was the age of manufacturing. And they had the steam engines built. They built trains, all these cabooses. They had cars. Eventually, beginning of the 20th century, they came up with the airplanes. And so, they were developing engines. So they were very concerned about this mysterious thing called energy. So energy was studied, whatever that was. It was studied in great deal by a lot of researchers. And they were trying to get to the bottom of it. But what were they trying to do? They were trying to do math. That's where the problem is. They were doing mathematics, not physics. They were doing experiments out there and then measuring and then coming up with equations. Well, that gave them a description. It did not give them an insight into what was causing this thing, and they call that unknown energy. And so the word energy entered the lexicon very strongly in the 19th century. It was there before then, right? But today, everybody talks about energy because it's the word that you can fit in anywhere you want. It's the wild card, so to speak. The joker in the rummy game, you can use it as any card you want. You just say energy and you're done. And nobody's going to question it because nobody knows what energy is. Why? Because it hasn't been defined. And second, no one knows if it's an object or a concept. There's all these problems. And everybody says, well, we don't care. That's just semantics. That's not physics. Physics is doing an experiment and measuring and giving you an equation. That's physics. Well, we beg to differ. Okay, no. And so here we have one fellow, and this was Julius Meyer, German guy, and he came up with this first law of thermodynamics. I guess his thermos was rolling, and he said, oh, thermodynamics, thermodynamics. And so what did they came up with this equation. It says change in the internal energy is equal to energy added to heating and minus energy lost due to work. That's in general terms what this first law of thermodynamics stands for, okay? And what does it mean in you could say in physical terms, because this is not even physical. Again, it's just a description. It says the total energy of an isolated system is constant. It's got to be a closed system, okay? And energy can be transformed from one form to another. For example, potential or chemical energy to kinetic energy. But what are they talking about? They're talking about accounting. All they're saying is we take energy over here and we turn it into a different type of energy over here. But what do we mean by that? Are we turning smoke into a solid rock? Is that what energy is? And no, the issue is that it's just an accounting procedure. It's saying, look, this part of the equation turns into that part of the equation because we go from potential to kinetic energy. Just a different type of aspect of this unknown called energy, undefined word called energy. The spirit turns from black to white, but we don't know what the spirit is, so to speak. That's more or less the situation. But can be neither created nor destroyed. Yeah, you can't destroy a concept. We try to destroy concepts, and it's very hard. You can't destroy distance. You can't destroy thought. You can't break the guy's head, then you can destroy thought. But you can't destroy concepts. You can destroy a chair. You can destroy a tree, a rock, a dog, things you can destroy. You can destroy a house. But you can't destroy a concept. What do you mean destroy a concept? How do you rip it? I mean, physically. We're talking about physics here, right? We're not talking about math. Can you rip a concept? Can you rip love? Can you rip grace? Can you rip intelligence? Can you pound it and say, I'm going to hit intelligence? You can hit the head, which kills the processes we call intelligence. But can you get intelligence out here and bang it and break it into pieces? So yeah, you can't create nor destroy energy because, it's nonsense to talk like this because energy is a concept. And yes, it makes no sense to say that you can, create or destroy energy. But it didn't stop there. Here you had another fellow. He came a few years later, also German. His name is Rudolf Clausius. And he came up with the second law, or started the second law of thermodynamics. And again, here you have the change in entropy. My God, what is entropy? Change in entropy is what? Equal the change in the heat transfer of within the system, right? Divided by the environmental temperature that you have out there. Okay, so you can see that all these people were working on equations. Why? Because they were interested in technology. That's what they were working on. They were doing experiments to understand this mysterious thing we call energy and how it works. And so they developed equations. What are equations? Descriptions. That's all they are. We have no explanation so far. First law, second law, whatever those laws are, we have no explanation of anything. All we have is a mathematical description. That's what these two so-called laws are. And that's what the mathematicians call them. They call them laws. Because it's a pattern, it's a repeatable pattern that they can measure repeatably, and they call that science, because you can measure the table repeatably. So you measure the table 1 meter. The other guy comes over and says, no, I measured it a little better, 1 meter, 1 millimeter. And the other guy said, no, you're wrong too. It's 1 meter, 1 millimeter, and 1 micrometer that I was able to measure. And so now you've measured more accurately. And the other guy comes with a ruler, he confirms, I say, oh, repeatable reading. And the other guy comes in and says, well, I repeated it too. So it's 1 meter, 1 millimeter, and 1 micrometer. All that's how much the table measures. And they call it a law, the law of the table. Is that what science is? Just measuring and giving you an equation, giving you a bunch of numbers and units, and calling them laws, the laws of God, I guess? And I don't know. Is that what science is about? Or is science explaining how Mother Nature runs this universe? That's what we want to know, understand. Okay, so here we go. How energy is used. This is, again, remember, this is 19th century, okay, primarily. This is when a lot of this stuff, all the engines were being developed, okay. The criterion by which energy is recognized as such is its ability to be transformed into work. Okay, you got to turn that into work, otherwise it's useless. But what are we talking about? This is technology. What does this have to do with understanding how the universe works, which is physics? This has to do with just describing a mechanical thing that works there, like a car works, how much energy you need, how much gas you need. They call that energy as well, you know. So you need so much gas, and it lasts so long if you run the motor at so much speed, etc., etc., etc. That's all technology. We still don't know what this energy spirit is. That's the issue. To use energy and say, oh, you put energy in your tank. Well, no, I put gas in my tank. Okay, so what is this energy that's being transformed? Are we transforming the gas into what? Into motion? Is that what it is? You know, again, it's easy to use this word energy whenever you can't fill in the blanks, and that's what these people do. It says, any body in motion possesses energy. Okay, what is energy? I mean, I possess it, great. Sometimes I don't have energy, but I guess I possess energy, whatever it is. I need to know what that energy is before, before I can use the word possess. You know, is it the same thing as possessing a dime in my pocket? Is that how you possess energy? Can we use that language in physics, what these people are using here? The energy of a moving body is called what? Kinetic energy. Kinetic referring to motion. Okay, but that's not the only type. There's another one. There are more kinds, but these are the main ones. Potential energy. An elevated body can also do work. It can acquire increasing speed. That is, kinetic energy when falling. The energy of an elevated body is called potential energy. Okay, so we have kinetic energy, which is energy of motion, and we have potential energy, static energy ready to be used for something. And again, all this has to do with technology. It has nothing at all to do with how the universe works. Okay, because you can't explain how the universe works using the word energy. Energy is a word of religion because first it's undefined. Then people say they don't know what it is. Then they don't know if it's a what, meaning a thing, or a concept. But they use it anyways. And anyone who attacks their sacred word is, heretic. and you're trying to kill their religion, and they say, you're doing semantics. You're just doing semantics. That's not physics. That's the way they handle it, because they have no answers, because they have no idea, like Feynman said there, they have no idea what energy is. And if Einstein, who had a Nobel Prize, could not tell the difference between an object and a concept, what can you expect with all these bozos that, that just dabble a little bit in so-called physics? They get into the mathematical physics, you wonder why they don't just go to church and pray. Because these are all religious people. Anyone using the word energy is a religious fanatic. That's all he is. He's trying to he wants to keep that word energy, because without it, his entire religion is lost. So energy is an extremely important word for them. You can't attack it because you're attacking their God. You're raping their virgin. Okay? This is the issue. Okay, so here we have a little if that shows that you can change one type of energy into another. You have potential energy at the top, and as you drop the ball, it loses potential energy, and you convert that into kinetic energy. So what transformation happened here? I mean, can you please tell me what changed into what? Did a dog turn into a cat? Is that what they're saying? Is this what we're talking about? It says when an object falls, it loses potential energy and gains kinetic energy. Gains, you acquire. Okay? And the increase in kinetic energy is exactly compensated by the decrease in potential energy. What did we learn? This is an accounting procedure. This is, you have your bank account, and you take money out of your assets and put it in the debit. And so you change your money from one type to another, from plus blue to red negative. Is this what this is? Potential to kinetic energy? What has changed here? What understanding can you get from potential being changed into kinetic, or chemical to kinetic, or whatever? What understanding do we have? I mean, the equation, you can even memorize and write the equation and pass the test. Say, well, yeah, so much potential energy changed to kinetic energy, and here's the equation that shows a transformation. Those are all descriptions. Just, joules turned into a different type of joules, maybe. What is that? That's nothing. We still have no idea what energy is it. Is it a cloud, like I showed earlier, some kind of smoke that's out there? Is it a spirit? What are we talking about? What has changed? Has the form of the energy changed? Again, did the dog turn into a cat? Did this smoke turn into a different type of smoke? Did it change its color? This is the issue. The issue is that this is not physics, using the word energy, or saying that you change one energy into another type of energy. You're not explaining the mechanism, what's happened, what's changed. All you're doing is describing something, not explaining what's going on in that invisible world. And the only way you're going to explain it is making that energy visible and finding out what it really is, if it is a what. If it is a what, and you have something physical, then you can say this changed into that, changed its form. Or it changed its structure, it went from solid to liquid, or something like that. And you can show what happened. And not describe it mathematically, but show exactly what changed. And then for that, you don't need the word energy. All you say, the dog turned into a cat. Then we all understand. It's very simple. You say the tree turned into a house. We can all understand that because we see the tree here, there was some manufacturing going on, it turned into a house. You see the dog here, there's some voodoo magic, whatever, and you turned it into a cat. Great. We all understand that. But to say that potential energy turned into kinetic energy, that's just an accounting procedure. That's your money from the assets to the liabilities. That's all it is. Okay, and since all these people did math, Einstein didn't stay behind, and he came up with this. Apparently, he's credited with it. I have my doubts that he was the originator of this equation, because they were already dealing with this kind of equation before then. Whether he was the one that really came up with it, I think you could say that it was like a group thing where several people already had these notions. Maybe he was the first one to formalize it. And in that sense, yeah, he probably gets the credit. But anyways, it says E equals mc squared. Great equation. Everybody just repeats it. Nobody understands what it means, but I mean in real physical terms. But everybody knows how to say that. Oh, E equals mc squared. And they say that's Einstein. They all know that. And that's Einstein's equation. Okay, but we had a problem. We don't know if it's mass or weight. And you say, Bill, it's mass. See, it's the little m. It says mass. Well, yeah, but we have this energy in special relativity where if the thing travels near the speed of light, it gains mass. Well, did it gain quantity of matter, which is the notion we have of mass, or is it pressing harder and harder against the scale, meaning its weight, right? So maybe it's weight times velocity of light squared. Maybe that's what they're talking about, okay? Or is there a difference between mass and weight? And then velocity of light or speed of light. Is that little c velocity or speed? What's the difference? Velocity has direction. Speed only has magnitude. It's a scalar. And so those are the first things you got to clarify. Then you got to clarify the other thing is, can a photon move in circles? One photon. Okay, can it move in circles? I don't know how you would draw the wave. You got a pinpoint wave and it's moving around. Maybe a wave packet, I guess. I don't know. Chop it off. At the ends, you have this little wavy thing, and it moves around in circles. Can one photon move around in circles? Around nothing, or even around something, I don't care. Can it move in circles? Okay, so these are the things you have to look at, because if it moves in circles, you're changing the direction. And like we held in a couple lectures ago, if you change the direction, you're changing the speed. But they're saying, oh no, we don't change the speed, we're changing the direction. Okay, but we have a problem with that because if you change direction, you have the centripetal force and the centrifugal force. They're canceling out, and that's why this thing is going around in circles. So you have an acceleration, which is known as centripetal force. That's an acceleration. And what they do is, instead of talking about the centripetal force that's pulling, that's tugging against the centrifugal motion, or force caused by the motion of something going around, it's being canceled, but it's still being pulled. Okay, it's this. Okay, that's what it is. You swing it around, okay, and you have both centripetal acceleration going in. There is an acceleration whenever something moves in circles. And so does light accelerate and just change directions? Is light being pulled from some center, like if it went around the sun? Can a photon travel in circles? So yeah, we have all these issues. But again, all equations, that's all they have. E equals mc squared, great. He gets a Nobel, he says, for that. He didn't get it for that. He got it for the photoelectric effect. But yeah, they could have given him a Nobel for E equals mc squared. What is that? That's a description. What have we learned? What have we learned about how the universe works? That's what I'm talking about. What have we learned about, what gravity is? What have we learned about what, light is, or what magnetism is? Those are the things people want to understand. And, you're not going to get them through equations. Okay, so here are my conclusions for today. Conclusions: energy is not a thing. There's no thing, no object, no entity called energy. No standalone thing that I can bring to you like this. I bring this ball to you and say, this is a ball. I can't do that with energy. Say, look, this is energy. This is a field. This is a wave. Transverse wave, right? This is a field. This two fields make a wave, This is time. I can't bring time and say, look, this is time. I'll show it to you. No, because for that it would have to have shape. Then you would say, then you can present it like that. But you can't do that with energy. So energy is not a thing because you cannot present it like that. Therefore, you can't use it in physics as a physical object, and therefore you cannot say that you're going to transfer energy, because you can only, in physics it's literal. I can transfer the ball from A to B. Here it is. I transferred the ball. That's called transferring the ball. I can't do that with energy. I can't say I transferred the energy. What have I transferred? I haven't seen it. Please make it visible. You need to make it visible, and for that, energy would have to have shape. Okay, and energy does not have shape. So you can't use it for mechanisms. What is a mechanism? Mechanism, what we do in physics. We do a physical interpretation. That's what physics is about. You need to give a physical interpretation of how something happened. Okay, and you can't use it you can't do that with energy, because you would have to show it first. First step is you got to show energy, point to it. And then you can say, okay, now I'm going to do this with that thing I called energy. Then you can do that. But first you got to point to it. For that, it has to have shape. You should be able to draw it. If you can't draw energy, you can't use the word. Not as an object, not in physics. Okay? Energy, it turns out that even as a concept, it's undefined. There is no definition of the word energy. We have no definition of the word energy today, okay? Because they have like 7 different types of energies, and they have potential energy, chemical energy, and kinetic energy, and who knows what else. They have all these energies out there, okay? And what are they? They're just equations. It's just like E equals mc squared. That's it. That's energy. The definition is what's on the other side of the equal sign: mass times velocity of light squared, or maybe it's weight times speed of light squared. Who knows? And then again, that squared gives you an idea. It's just an equation. That's not a definition. Okay? That's just an equation. That's a description that they're going to use in mathematics. Okay? We don't have a definition written out, because whatever you write out is wrong. They have 10 different types, and they use all 10 simultaneously. And then energy is a mathematical concept. So what is it? It's a spirit. It's the same word as spirit in the old traditional religions. No different than the word spirit. It's religious people who have taken over so-called physics. It's known as mathematical physics, also known as science. That's the people who run it, are religious people. They're people who memorize, pass their test at the university, get their PhDs, and then they just blab the same thing over and over to the next generation. We've been doing that for 400 years now. And essentially, energy is a wild card. Whenever you're ignorant, whenever you don't know anything, you say energy, and people say, he's so intelligent. He used the word energy. Okay? That's what it is, a joker in a rummy game. That's what energy is.